Dry Ice Rainbow with Ayesha and Ayesha. Dun dun dun. Let's go. Snap. I have no idea where the magic snap thing went after that, but we're just gonna deal with it. Look at the colors. First, the first bottle is phenolphthalein, which is pink. The second bottle is phenol red, which is red, of course. The third bottle is methyl orange, which is a light orange or yellow. The fourth bottle is methyl red, which is an olive green color. The fifth bottle is Universal Indicator, which is a tealish greenish concoction. The sixth bottle is Bromosil Green, which is a light blue. The seventh bottle is Methylene Blue, which is a dark blue. The eighth bottle is Crystal Violet, which is a dark purple. And the ninth bottle is Litmus, which is a light purple. Let's take a look at the colors all close up. So pretty, so amazing. Wow, 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 wow. When the warm metal bar touches the dry ice, it vaporizes a little of the dry ice, which makes a puff of gas. It literally screams at you, this is no puff of gas. Okay, so here is us putting dry ice into phenolphthalein, which look at it bubble, look at it, and boom, oh my gosh, it turned clear. What is this sorcery? What is this magic? How could this happen? OMG, wow, 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 wow. Look at it, so crazy. Just admire it, just look at it. Feel the coolness from the video, from the screen. And we're still looking at it. No, fast forward to the fennel red, which quickly turns into yellow. OMG, what is this magic witch thing? And now the methyl orange, it turns darker, believe it or not. The change is there. Now the methyl orange. The methyl red, which slowly turns into red, believe it or not. We just have to wait for it to see. The universal indicator quickly turns into this greenish yellowish concoction color, and the next three have no change, so they're just there for looks. But look how yummy they are to look at. And lastly, we have Litmus that quickly changes into light pink. Oh my goodness, look at it, look how pretty. Wow, wow, crazy. Here's another shot of everything. Again, try to feel the coolness from your screen. Look at all the bubbles, this witchcraft voodoo magic thing. Wow, so crazy. And here's everything after the craziness has gone down. Look how pretty and rainbow. Dry ice goes through a phase called sublimation. Sublimation is when a solid turns into gas. Since dry ice is frozen carbon dioxide, there is no liquid inside of it, hence the name dry ice. When working on dry ice, it is most convenient to work quick and fast. As the dry ice sublimates, carbon dioxide is released into the air, which could cause asphyxiation, so working in a large open environment is highly recommended. The chemical equation for dry ice rainbow is displayed on the screen. As you can see, it starts off as carbon dioxide and water and goes through a phase called carbonic anhydrase, which creates carbonic acid and then transforms to bicarbonate and a hydrogen ion, which creates the pH change. Speaking of pH, in our experiment we have 9 acid-base indicators, so when you add the dry ice, it lowers the pH levels, allowing the solutions to change colors. Let's take a look at some of the indicators used in our experiment. Fennel red turns from reddish pink into yellow. It first has a pH level above 8.1 that reveals a pinkish color after adding acid, or in this case, dry ice. It quickly plummets to below 6.2, changing the color to yellow. Another example is phenolphthalein. In our experiment, it turns from bright pink to clear. It goes from a pH level of 10.2 and quickly turns clear, resulting the pH to be at about a 7. Both phenolphthalein and phenol red are acids. If you add acid to a solution, the concentration of hydrogen ions or acidity increases and the pH level decreases. This is a chart for the phenolphthalein color change. Now it's time for Orange Fizz with Ayesha and Aisha. What? Alright, so the ingredients that we will need is an orange or a cutie, whatever you choose, and baking soda plus a little teaspoon of your choice. We are using a pink spoon, of course. Look at. Next, we are putting the baking soda onto the plate as shown. And I'm telling you this right now, do not add too much baking soda because literally this is what happens when you add too much baking soda. Oh, and we're off. We ran. It literally chased us down. We disappeared. Like, literally. Alright. Here's another warning of us putting too much baking soda. It literally tastes like fish, and I felt like throwing up. So, if you want to throw up, go for it. That's all on you. Here you can see the baking soda fizzing on the orange. This is what causes the orange to fizz up in your mouth. And here it is in action. How does orange fizz up? Well, baking soda is a base and the orange or lemon, whatever is your choosing, is an acid. When you mix an acid and base, it creates tiny little bubbles as shown in one of the videos, the previous one specifically. Those tiny little bubbles are carbon dioxide. So when you chew the orange, the more fizzy it will get. Just be aware it does not taste good. How many times do I have to say it? I am literally warning you guys. And thank you for watching. I hope you guys had so much fun. Alright, goodbye.